Hello. So, yeah, welcome. So, today we are going to look at different types of exponents. So, now what we're going to look at is an exponent in which the base is just an arbitrary positive real number, which is non zero. So, that's what we're going to learn. So, we're going to talk about the rules on how do we differentiate functions of this form. You see. So, to differentiate functions of this form, we need the following result. So there's an identity that we need to know every time when you want to differentiate functions of this form. And the identity goes as follows. It says that a to the any power f of x is just identical to e to the power f of x ln of a, like that. So every time when you want to differentiate any exponent, you first have to convert it to base e. So the only way you can convert from base a to base e is by making use of this identity. You see, so one of these things that you must know is that most people, they always get confused about this part. So the natural log, it is just a number. There is nothing special about it or anything that makes it complicated. It's just a number. So that's why you don't have to worry so much about it. So this identity gives us a way on how we can convert from one base to the base e, because it's only the rules that we have learned, they only apply when the base is e. So when the base is a, you can't apply that rule that we have just learned on how to differentiate exponentials. It only works when the base is e. So what we need is to just know a route on how to convert from one base or from one arbitrary base to the base e. So to do that, you just have to make use of this identity. So to practice now, let's look at the following example. So a typical problem then will be if g of x is given as 3 to the power x, find g prime x. So if you're given that, how can you find g prime x? So to find g prime x, this is how we proceed. You see. So to find g prime x, first we have to understand, according to the identity, this g of x that is given, it's none other than e to x ln 3, like that. You see, so this g of x is given like that. So therefore, then what becomes g prime x? So to find g prime x, now we know the whole procedure. I first take the power or the index of the exponent and differentiate it. So if you differentiate x, it becomes 1. So what remains is just ln 3. Then you bring down that ln 3 downstairs. And then now the next thing is you bring the exponential as it is. So you bring e to x ln 3 like that. But this can be further simplified as follows. So if you look, this e to x ln 3 that we have here, it is just similar to 3 to the power x. So it means this can be further written as 3 to the power x ln 3 is our final solution, like that. You see. Okay, so another example different from this one. Let's see. So given that y is equals to 3 to the power x squared minus 1, find dy dx. So given that, how can you find dy dx? How can we find that? So again, what do we have? So we have that. So if we apply our rule identity, we can convert that to base e. And our conversion means that this will become e to x squared minus 1 and ln 3. You see? So nothing must confuse you here, because this thing that we have here, if you are to expand it, it will become x squared ln 3 minus ln 3. So we now know that every time when you want to differentiate an exponential, the first thing is you begin by differentiating the index of the exponent. So when you differentiate the index of the exponent, we see that first you differentiate this one, then this one will give you 2x ln 3. So when you get 2x ln 3, you bring it down. So you have 2x ln 3. When you differentiate negative ln 3, it's a constant, so it becomes 0. So you're done. Then next you bring the whole e to and its power next to that. So we get e to x squared minus 1 ln 3. But already we know that this e to the power x squared minus 1 ln 3 is the same as saying 3 to the power x squared minus 1. So which means what we're going to get now is 2x dot 3 to x squared minus 1, then ln 3. That becomes the final solution. So this is how you differentiate exponents whose base is not e. So yeah, thanks for watching, guys. So we're gonna end it here. Bye. See you on our next lesson.